So friend, today we are going to learn on symmetry of a curve. Particularly we will discuss here the symmetry of a curve which is in Cartesian form. At the end of this topic you will be able to summarize the rules for symmetry of curve, discuss the concept of symmetry. So let us consider the definition of symmetry. Here we consider a very simple definition of symmetry. Symmetry means the quality of something that has two sides or halves. Halves means two separate parts. Yeah, half parts. Two sides or halves that are the same or very close in size, shape and position. So to understand this, consider these examples. In the first example, we can see the image of face of dog. So about this line, on the left hand side of this face, the shape and size of this face is same as the right hand side. Therefore, this whole face, this whole body of dog is symmetrical about this vertical line. Therefore, this is symmetrical about this vertical line. In the second example, consider the equation of parabola ax square plus bx plus c is equal to y. So this is the parabola which passes through this vertex, and this parabola lies in first and fourth quadrant, and this is the line passes through vertex x is equal to minus b upon t, so b upon a. So we can see here that this curve has two equal parts about this line. Therefore this curve is symmetrical about this vertical line x is equal to minus b upon 2a. And in the last example we can see the two images, and these two images are symmetrical about each other about this vertical line. So this is what about the simple definition of symmetry. Now we must know what do you mean by asymmetry. What is the meaning of asymmetry? That is, asymmetry means that is the absence of symmetry or violation of symmetry. In this figure we can say that the left hand side object is symmetrical about the vertical line, and the right hand side object is not symmetrical about this vertical line. Therefore this object is asymmetric. But how to check symmetry mathematically? So if the equation of curve is provided in Cartesian form, then how to check whether that equation of curve is symmetrical about x-axis, y-axis, about both axes, x and y axis, whether that curve is symmetrical in opposite quadrants, whether that curve is symmetrical about the line y is equal to x and about the line y is equal to minus x. So there are some rules. So let us consider these rules one by one. So if we want to check whether that curve is symmetrical about x-axis, then in a whole equation let us look out that if the even powers of y are there, then we can say that the given equation of the curve is symmetrical about x-axis. If in the given equation only powers of x are even everywhere, then you can say that the equation of the curve is symmetrical about y-axis. And if both the variables x and y appears present everywhere with the even powers, then you can say that the given curve is symmetrical about both axes. For the opposite quadrant, x and y, just replace x and y by minus x and minus y respectively, and let us look out check out whether the equation of the curve changes or not. If that equation of the curve remains same, then you can say that the given curve is symmetrical about opposite quadrants, and if the given equation changes, then you can say that it is not symmetrical about that opposite quadrants. About the line y is equal to x is changed to y and y is changed to x, means interchange the role of x and y and see whether that equation of the curve changes or not. If changes, then you can say that it is not symmetrical about the line y is equal to x, and if that equation remains unchanged, then we can say that the given curve is symmetrical about line y is equal to x. Similarly, we can check out the symmetry about the line y is equal to minus x changed to minus y and y changed to minus x after this replacement in the given equation of the curve, and if that given equation of the curve going to change, then you can say that the given curve is not symmetrical about the line y is equal to minus x. And if after that replacement, if the equation of the curve remains unchanged, then we can say that the given equation of the curve is symmetrical about the line y is equal to minus x. Now for illustration, consider some examples. So about x-axis, y should have even powers within the given equation. So this is the one example, y square is equal to 4x. So this is the equation of parabola. In this equation, y appears with the even power 2, therefore this is symmetrical about x-axis. So we can see here in this figure. Similarly, the second example, y square is equal to minus 4ax. So this is the curve and this is the x-axis. Only even power of y is there, therefore this curve is symmetrical about x-axis. We can similarly discuss the symmetry about y-axis. Here x should have even powers. So x square is equal to 4ay. This is the equation. This is the equation of the curve, and this is the curve, and this is the y-axis. So this curve is symmetrical about y-axis, and this second example also shows that this curve is symmetrical about y-axis. About the line y is equal to x, as we discussed that just interchange x and y within the given equation, and let us check out whether the equation of the curve going to change or not. So we observe here that if x is replaced by y and y is replaced by x, similarly here, so we can see that there is no change in the original equation of the curve, therefore this is symmetrical about the line y is equal to x. Symmetry in opposite quadrants. If x is replaced by minus x and y is replaced by minus y in the given equation of the curve, and if equation unchanged, then you can say that the given curve is symmetrical about the line, symmetrical in opposite quadrants. So these are the some more examples for your practice. Do this practice and try to complete.